So now I'm going to show you one of my favorite websites, Khan Academy. I'm going to pull it up and make it full screen. Khan Academy is really nice because it has videos on so many subjects. As you can see here, it says they have over 3,300 educational videos. You can choose what topic you're looking for. I am going to choose math and arithmetic and pre-algebra because that's what's appropriate for middle school students. You can look around, and if you're having problem with a certain kind of thing, you just look for a video that's on that subject. I like to use things like the lattice multiplication because different people understand math in different ways. That's pretty obvious. And lattice multiplication is a twist on the way we have usually looked at multiplication. You just click on it, you click play, and you can make it full screen.
I'm going to do a couple of lattice multiplication examples in this video, and in the next one we'll try to understand why it worked. So let's say we're trying to multiply 27 times 48. What you do is you write down your 27. The 2 and the 7 are going to get separate columns, and you write your 48 down the right-hand side, and then you draw a lattice. This is why it's called lattice multiplication. So the 2 is going to get its own column, the 7 is going to get its own column, the 4 is going to get its own row, and the 8's going to get its own row. Now the fun thing about lattice multiplication is you get to do all of your multiplication at one time, and then you can finish up the problem with all your addition. You don't have to keep switching gears by carrying and all of that, although there is carrying, but it's all while you're doing the addition step. Now we're almost done with our lattice. We actually have to draw these diagonals here. We'll understand in the next video why these diagonals even work. Just like that. And now we're ready to multiply. 7 times 4 is 28. 7 times 4 is equal to 28. So you write down a 2 and an 8, just like that. 2 times 4 is equal to 8. So you write down a 0, 8, just like that. Then you have 7 times 8. 7 times 8 is equal to 56. So we write down a 5 and a 6. And then finally 2 times 8 is equal to 16. So you write down a 1 and a 6. Just like that. And we're done all of our multiplying. Now we're ready to add. So what you do is you go down these diagonals that I drew here. So this first diagonal, which is really the ones diagonal, you just have a 6 sitting here. So you write a 6 just like that. Then we move over to the next diagonal. This diagonal with the 6, 5, and 8 in it. That's our tens diagonal. So 8 plus 5 is 13. 13 plus 6 is 19. So you write your 9 right here in the tens place, and now you carry the 1 and 19 up there into the hundreds place, because this isn't just 19, it's actually 190. It's 19 tens. Anyway, you carry your 1, you have 1 plus 2 is 3, 3 plus 8 is 11, 11 plus 1 is 12. You write the 2 in your hundreds place, and you carry the 1 into your thousands place. 1 plus 0 is 1, so you just have a 1 in your thousands place just like that. And you get our answer. 27 times 48 is equal to 1,296. 1,296. Let's do a harder problem, one that requires more digits, just to show that this will work.
As you can see, the lattice multiplication way worked. I'm going to go to his second video now because I think it's important to see not only will it show you that a particular method works, but he can also show you how that method works.
In the last video, we did a couple of lattice multiplication problems, and you saw it was pretty straightforward. You got to do all your multiplication first and then do all of your addition. But let's try to understand why exactly it worked. It almost seemed like magic. And to see why it worked, I'm going to redo this problem up here, and then I'll also try to explain what we did in the longer problem. So when we multiplied 27, so you write your 2 and your 7 just like that, times 48, just doing exactly what we did in the previous video. We drew a lattice. We gave the 2 a column and the 7 a column, just like that. We gave the 4 a row and we gave the 8 a row. And then we drew our diagonal. And the key here is the diagonals, as you can imagine. Otherwise, we wouldn't be drawing them. So you have your diagonals. Now, the way to think about it is each of these diagonals are a number place. So, for example, this diagonal right here, that is the ones place. That is the ones place. The next diagonal, I'll do it in this light green color. The next diagonal right here in the light green color, that is the tens place. Now the next diagonal to the left or above that, depending on how you want to view it, I'll do this little pink color right here. You could guess. That's going to be the hundreds place. And then finally we have this little diagonal there, and I'll do it in this light blue color. That is the thousands place. Is the thousands place. So whenever we multiply one digit times another digit, we just make sure we put it in the right bucket or in the right place. And we'll see what I mean in a second. So we did 7 times 4. Well, we know what 7 times 4 is 28. We just simply wrote a 2 and an 8, just like that. But what did we really do? And I guess the best way to think about it, this 7, this is the 7 and 27. So it's just a regular 7, right? It's just a regular 7. But this 4, it's the 4 and 48. So it's not just a regular 4, it's really a 40, right? 48 can be rewritten as 40 plus 8. This 4 right here actually represents a 40. So right here, we're not really multiplying 7 times 4. We're actually multiplying 7 times 40. And 7 times 40 isn't just 28, it's 280. And 280, how can we think about that? We could say that's 200s plus 8 tens. And that's exactly what we wrote right here. Notice, this column, or sorry, this diagonal right here, I already told you it was the tens diagonal. And when we multiplied 7 times 40, we put the 8 right here in the tens diagonal. So that means 8 tens. 7 times 40 is 2 hundreds. We wrote a 2 in the hundreds diagonal, and 8 tens. That's what the 28 here is. We actually wrote 280. Let's keep going. When I multiply 2 times 4, you might say, oh, 2 times 4, that's 8. But what am I really doing?
Again, this website is just really useful for learning new things, such as the lattice method, or going over different topics that you have already learned. It's really nicely laid out. There are so many videos, and Can does a very good job in explaining all the way from basic mathematics to calculus and other subjects.